Well, Jai Hind students, today we will be starting with the testing unit of software engineering. The name of the subject is software engineering and the paper code is KCS 601. So we will be dealing with the testing, what actually is software testing, why there is a need for software testing and why do we perform the software testing. Now, what is testing? As far as testing is concerned, there are many people who understand many definitions of testing. So it's very important for us to understand what is the exact definition of testing, right? Testing is basically the process of demonstrating that errors are not present. So it is a very common type of definitions which many people thought about testing is that it is simply a type of process with the help of which we can demonstrate that different errors are not present. That means it is something which basically shows that errors are not present. So can we say that this is a proper definition of testing? Of course not. This is not the proper definition of testing. We'll be dealing with what actually with the concept of testing is in the later slides, but let's understand what people actually think about it. So it is not the process of demonstrating that simply errors are not present in a particular state of code. Second is that the purpose of testing is to show that the program performs its intended functions correctly. Like there are a number of people who used to think that if you are talking about testing, it is something based on which we can show that a particular program is functioning correctly. Then we can say that it is what is called as testing. So is it again a proper definition of testing? Of course, this is also not the proper definition of testing. Third is that it is a process of establishing the confidence that a program does what it is supposed to do. That means a very general scenario which we generally have to think in our mind that it is something which is going to give a proper type of confidence that the program is doing what it is supposed to do. So all these definitions are not the correct definitions of testing. These are the incorrect definitions of testing, and in general we think that these are the correct type of definitions. So let's understand what actually do we mean by software testing. Now, the more appropriate definition is it is a process of executing the program with the intent of finding an error. So it is something which basically shows the presence of a particular type of error in the code. The process of executing the program with the intent. That means what is basically the intention? The intention is basically to find out the error in a particular piece of code. That is what is the most appropriate definition of testing. And as far as this testing is concerned, we always used to perform this testing with the very basic type of concept in our mind that we are going to perform it with the intention of finding out an error in a particular piece of code. So this is the most appropriate definition of testing. Now, why should we test? What is actually the necessity of testing? Can we deliver the particular product to the end user without testing it? Or what are the type of consequences we can have later on if we are going to deliver the software without testing it, right? So although software testing in itself is an expensive activity, yet launching of software without testing may lead to cost potentially much higher than that of costing, especially in system where human safety is involved. So it is a very important thing that we are very much aware of this concept that of course it is a very type of expensive activity. But again, it is so important that we should not deliver a particular product to the end user without testing it. So first and foremost thing is that it is mandatory that you have to perform testing. And without testing, we are not going to deliver the product to the end user. Second, the consequences that if you are going to deliver the product to the end user without testing it, it can be very harmful in the term of human safety, where this human safety is basically involved. So never ever thought of delivering the particular product to the end user without testing it. It is mandatory and one of the most important phase of your software development life cycle. That means we have to test the software and then only we are going to deliver it to the concerned person. Now in the software life cycle, the earlier the errors are discovered and removed, the lower is the cost of their removal. So it's very easy to understand even. As we are having like number of phases in SDLC, the earlier you will be able to find out any particular type of error in the code, the easier as well as in terms of cost, the lower will be the cost to remove that particular type of error. The later we will be able to find a particular type of error, the more costlier it is to resolve it. So it's better to find out or to get the particular error at initial level so that the cost of this testing is basically lower down. So it is one of the most important factor when we are dealing in terms of the development of a particular software. So it's important that we should be able to get the errors as early as possible so that the costing of, the cost of this testing becomes lower. Now, who should do the testing? Who all are the persons who are basically involved in the concept of testing? The testing requires the developers to find the errors from their software. Again, it is very difficult for software developer to point out the errors for their own creation. This is one of the most important points, students, that the person whosoever has written the code, if you will ask that individual person to find out the errors in the code which they themselves have written, so it is very, very difficult for them even to realize that the code which they have written, I mean, according to them, it is of course perfect. And they'll not be able to find out any particular type of errors in that particular code which they have written. So, many organizations have made a distinction between the development and the testing phase by making different people responsible for each phase. So, it is not actually the developer who is going to test a particular software. Because if they are going to test that software which they themselves had developed, it's very difficult that they'll be able to find out any particular type of errors in that particular code. So there is a separate team, that there is basically the team of the testers who basically perform testing. There are basically specialists who are specialists in a particular task of testing, and they are the person who are going to perform this testing. That is the most important thing. Now, what should we test? What are the consequences and what are basically the things that we are supposed to test? We should test the program responses to every possible input. So whatever inputs we are giving, we should try to test the program with every possible set of inputs, and we'll like to know how the program is basically going to respond based on the what inputs we are actually giving onto the system. It means we should test for all valid and invalid inputs. So it's not actually only the valid inputs that we are going to test. We should also check for the invalid inputs also. The system, of course, is going to work properly if we are going to, have fulfill all the proper rules and regulations, and we are going to produce these valid inputs. Of course, it is going to work. But how the system is responding if we are going to give some invalid type of inputs to the system? So we should always try to test the software for whatever valid inputs we are giving and whatever invalid inputs we are giving onto the system. Now, what are the testing objectives? With what objective we should perform testing? Software testing has different objectives. The major objectives of software testing are as follows. First is, of course, finding out the defects in a particular piece of code is the most important objective of software testing. Finding defects which may get created by the programmer while developing the software. So when an individual is developing a particular piece of code or a software, of course, there can be number of defects which can be created during the time of programming. So what is the main objective of testing? The main objective is that we should be able to find out the defects which have been created by the developer when they are actually going to develop this particular code. So the important thing that we should be able to find out the defects. Second is to make sure that the end results meet the user requirements. See, initial is the thing that what is basically the requirement of the end user. So based on the requirements of the end user, we should be very much sure that whatever end results we are getting, those end results are going to meet the requirements. Okay, that is again the main objective, that we should be able to get a particular piece or a particular software which is going to work properly according to the requirements of your end user. Third is to ensure that it is going to satisfy the SRS, that is software requirement specification. All the requirements, the functional, the non-functional, every requirements need to be properly mentioned in your SRS, which is the very first phase, right? Very first document that need to be created, and based on which we are actually very much aware what the requirements of an individual are. Now, with the purpose of this testing, and if you are going to perform this testing in the proper way, the again objective is that we are going to ensure that whatever requirements have been properly incorporated in the SRS, they have been properly satisfied based on what the output we are getting out of the system. So again, this is the most important activities. So it's not like that in SRS we are mentioning something else and at the end we are getting something else. So whatever requirements we are having initially, and that is properly mentioned in your SRS, with the objective of that particular testing, we should be able to achieve a software which is going to work properly with what all are the requirements which is mentioned in your SRS. Next is to gain the confidence of the customer by providing them a quality product. Of course, if you are going to deliver the particular product to the end user, which we have actually, or which the tester have actually not tested, it is definitely not going to give a particular type of confidence to the customer as well. Of course, if we have tested the particular product and then we are going to deliver that particular product to the end user, it is going to give them a proper type of confidence and of course providing them a qualitative type of product. And this is something that we actually don't want to compromise with. Quality again plays a very, very important role in the software development life cycle, right? So we don't want to compromise with the quality of a particular software. And if you're doing it in the proper way, the main objective is that we should be able to provide the software which is again going to give a good confidence to your end user and something in the form of quality, which is a most important thing that everybody is looking for. Now, the next is the principle of software testing. Like there are a number of different principles of software testing. I'm going to deal with each and every one in a brief now. Testing is something which basically shows the presence of defects and not the absence of defect. That is the most important thing. Exhaustive testing is not possible or impossible. Early testing will be dealing about what is defect clustering, the pesticide paradox, testing in context department, and lastly is absence of the error fallacy. Now let's discuss them. Now there are some other principles as well. Testing must be done by an independent party. So it's not like that, as I told you, that the developer whosoever has developed the code is the one who is going to perform testing. It is the type of activity that again need to be done by the independent party. Again, best person should be given this particular task of testing. The person who are expertise in that individual domain, who are testing experts, the person who are the specialist need to be given this particular task of testing. Test for invalid and unexpected input condition as well as valid condition. That means it's not only the valid condition based on which we are going to perform the testing. We should perform it based on the valid, based on the invalid conditions as well. Keep software static during test and provide expected results if possible. So what are the results that we are expecting out of the source system or the software? Should be able to provide that particular type of results. Now let's discuss all these different type of principle a little bit in more detail. First is, as I told you, it is something which basically shows the presence of bug, not the absence of error. Testing is an application that can only reveal that one or more defects exist in the application. Testing alone cannot prove that the application is error-free. Therefore, it is important to design test cases which find as many defects as possible. So, it's very easy to understand that we should be able to design a test case which has the highest probability of finding out an errors in the particular case. We will never say a particular test case as a good test case which is not able to find out any particular type of defect. So, good test case is one which has the highest probability of finding out any particular type of defects in the particular piece of code. That is important thing. Exhaustive testing is impossible. Unless the application under test has a very simple logic structure and limited input, it is not possible to test all possible combinations of data. For this reason, risk and priorities are used to concentrate on the most. See, this is most important thing, that if we talk about complete testing, it is it is totally impossible, we can say. If we have a small data set, if we have a very simple logical structure, of course, we can move on when we have a small piece of code. But when we have a very big type of code, we cannot go for the complete type of testing, right? What is basically the reason? Because the number of test cases are again unlimited inside. And to test for each and every particular type of test case is practically neither feasible nor possible. So that is why we generally used to say that it is something which is based on which we can say that if you're talking about complete testing, it is generally impossible in nature. Third is early testing. As I told you, the earlier we are able to find out any particular type of fault in the system, the easier, and in terms of cost, it is going to incorporate less cost as compared to the one if the error we will be able to find out at later stage in your software. So the sooner we start the testing activities, the better we can utilize the available time. So we should always try to find out the errors quite early, because it is easy for us to recover it, to remove those particular errors at your early stage. The later, if you are going to find out in terms of cost also, it will be very, very costly to find out and to find out the proper measure, to find out how we can actually solve those particular type of errors. So soon as the initial products such as requirement, those design documents are available, we can start testing. It is common for testing phase to get squeezed at the end of the development when development has finished. So by starting testing early, we can prepare testing for each level of development testing particular life cycle. So it's very important that we should be able to try to fetch the errors in the particular piece of code as early as possible in the software development life cycle. Another important point is that early testing is that what defects are found earlier in the life cycle, they are easier and cheaper. These are the important terms, that they are very easier to repair and they are again very cheaper to repair. It is much cheaper to change an incorrect requirements that have to change the functionality in the last system. So we should always try to get the errors as early as possible. Now, next is defect clustering. Now, what is this defect clustering? During testing, it can be observed that most of the reported defects are related to small number of modules. That means in a small modules, we'll be able to find many number of, the type of defects we can say. So we can find out or report different type of defects in a small number of modules within a particular type of system. That is, small number of modules contain most of the defect. A small module is there and that particular small module is containing, many type of defects in the particular system. In the system, this is application of Pareto principle of software testing. Now, what does this particular principle says? This simply says that approximately 80% of the problems are found in 20% of the modules. This is a very important line, that 80% of the problems can be found in just 20% of the modules. Next is the pesticide paradox. If you keep running the same set of test cases over and over again, chances are no more new defects will be discovered. So what is actually the scenario? That we will always try to test the data based on the different type of test cases. If you are going to run those very test cases again and again, it is but obvious that we will not be able to find out more errors in the particular piece of code. And as I told you, test case, a good test case is one which has the highest probability of finding out an error in the particular piece of code. So we should be able to try to generate the test cases which has the highest probability. And like if you are going to run the same test cases again and again, the probability of finding out an error again is very, very less. Now, because as the system involves, many of the previously reported defects will have been fixed and the old test cases do not apply anywhere. Anytime a fault is fixed or a new functionality is added, we need to do regression testing. Now, what is this regression testing? Whatever, if we want to incorporate and if we have incorporated any particular type of change in the software, we again need to test the software. That type of testing is basically called as regression testing. So, though we have tested the software initially at trial level also, but due to the changes that we have incorporated in a particular software, any change, we are going to perform the testing again, which is basically called as a regression testing. However, those regression test cases also need to change to reflect the changes made in the software to be applicable and hopefully find new type of defect. So, because it has generally been thought about that if we are going to incorporate any particular type of change, there may be the modules which may not be working well earlier, may not be working well right now because of the changes that we have incorporated into the software. So, it's very important to make sure that the modules which were earlier working well are presently working well or not. We have to perform this very type of testing after incorporating any particular type of change. This is what is basically the concept of regression testing. Now, next is testing is context dependent. What is this? Different methodologies, techniques and types of testing is related to the types and nature of the applications. Few examples, software application in medical device needs more testing than game hardware. So, it is something, depending on the type of applications that we are dealing with. There are a number of applications which of course require more testing as compared to the other application which may require some a lower amount of testing, we should say. So, it is something which is dependent on the particular type of context that need to be properly tested. More importantly, a medical device software requires risk-based testing to be compliant with medical industry, regulatory and possibility. And by the same token, a very popular website need to go through rigorous performance. So, it is something which is dependent on the type of context that we are dealing with. Some may require enough level of testing, a thorough type of testing. Another may be the scenario which may not require, so thorough type of testing. So, it is something which is actually dependent on the type of context that we are dealing with. Now, last is the absence of error fallacy. Just because testing didn't find any defects in the software, it does not mean that software is ready to be shipped. when the executed test really designed to catch the most defects, or where they designed to see that software match the requirements. There are many other factors that need to be considered before making the decision to ship the software. So it's very, very important thing that what is there, we need to show, it is something which basically shows the absence, that why absence of the type of absence of error policy. So if the system built is unusable and does not fulfill the user needs and expectation, then finding and fixing defects does not help. So it is very, very important that we should be, very much clear about these different principles of testing, what is basically the objective of testing, and then only based on these criteria in mind, we should be able to perform this very type of testing. Rest about the types and the basically levels of testing we are going to discuss in the next lecture. Thank you so much, students. Thank you.